Yes, so very good afternoon. Am I audible to you all? Just please write yes on our chat box if I am audible to you all. Okay, thanks, Imani. Uh, yes, thanks, Aman. Uh, just give me 1 second so that. Yes, currently in ST1 we have covered till 20th lecture, and in a previous week we have done three parts. There is a first one is a just introduction to the unsupervised learning, and the second topic is k-mean clustering, and the third topic is hierarchical clustering. So in this week we will cover the regression, which is a part of a supervised classifier, and there are two categories that we will cover in the syllabus. That is, the first one is a linear regression, and second one is a locally weighted register or logistic regression. And next week we will do uh, reinforcement learning and evaluation metrics. So this is a pending uh, for the next week. And today, let us start with the regression. But before we start with the regression, we have to. There are some two topics which are still pending. 1 second. Which are still pending. Uh, there are. Let us start with that topic. Yeah, we will start this regression a little bit later. And previously, we have covered there are some topics which are just we have two or three slides related to the hierarchical clustering, and there are some which is related to the measuring the distance of two clusters. So just I have to give the overview so that you can remember what we have done yesterday and where we are yesterday. And okay, this is a part of our hierarchical clustering, and in a hierarchical clustering we have done. Yeah, in a hierarchical clustering, we have just done the overview of a hierarchical clustering that includes the two types. That is, the first one is a agglomerative, and which follows the bottom-up approach, and another one is a divisive, and which follows the uh, top to bottom approach. And how they are following these two approaches, then this we have done. Yeah, this one is a agglomerative, which following the bottom to upper approach, and another one is which following from the top to bottom approach. So this is these two types, and these are the examples that we have covered. 1 second, let us start with the this slide so that you can remember it. So in case of a first approach, that is which follow the bottom to upper, this one is a bottom part, and this one is a upper part. So top, you can say that there is a top or a upper, and the agglomerative, which follows the bottom to up approach, in which first we have to assign the, for example, these are some points are there. First, we have to just make the cluster of these points, and then we have made this cluster and this type of a cluster. Then we have made this cluster and this cluster. So that point of view is generally referred to as a bottom to up approach. So which is a bottom to upper approach, which is referred to as a agglomerative. And another one is a divisive, and in a which follows the upper to bottom approach. So this one is basically example for this, and another one is a which follows from the top to bottom, that I will explain with the help of this. For example, the same points are there. these are same points are there. First, we have to draw this circle, for example, this one. Then we have to made this cluster, kind of, you can see that. Yeah, and then we have made the subparts. So that is, in this approach, this is a, difference between divisive and agglomerative. This is, you can just write it as a divisive and uh, agglomerative. So these two approaches that we have done under the hierarchical uh, approach, and there is a next part in how to identify the distance between the two clusters. So there are some different methods are available. So once I have to check it out, is there someone? Yes. Yeah. Now on the hierarchical clustering, there is a next part that includes the measuring the distance between the two data points or between the two clusters. So let us start with there are basically three types of links, and this is a, distance between the two or two data points or a two clusters, which is referred to as a link. So there is another word which is associated with the measuring the distance. So in a complete, let us start with the in a complete linkage hierarchical clustering. So the distance between the two clusters is defined as the longest distance between the 2 points in each cluster. So how we can just see it as a like this, and here you can see it as a. Then we will definitely doing in details in our upcoming slides. Uh, you just have to remember that what we are doing in measuring the distance between the two clusters. There is a first one is a single link or a simple link. So in a single or simple link, we have to just find out the first we have to check the shortest distance between these two clusters, and how we can identify that this kind of a shortest distance via data points. So this one is a, for example, this one is a one cluster and this one is a second cluster. And here you can see that this x is too far from this x, and this x is also too far from this x. So this x is very near to this cluster one. So the for example, there is a this x of cluster one is very near to the two. So we can say that we have to just assume that these two x's, and we have to identify the distance between these 2 points. So if we are finding the distance between the shortest by following the shortest path between the two clusters, then it is referred to as a simple link or a single link. In another point, there is a average. So here you can see that there is an average. In an average, we have to just take the center point or a centroid of the cluster and identify the distance between these two clusters without any consideration towards the data points. So these axes are representing data points, and yes, it is also noted that you have to ignore these axes. You no need to consider this kind of a axis. This is not just an and the definition of these axes are basically these are data points. So you have to ignore these data points, and because it is ignored by this cluster, so you no need to consider that first of all. And this is identify the distance, the average linkage, identify the difference between two data clusters on the basis of their centroids or the center of the cluster. So the another one, which one is also important, there is a complete linkage, and this is the actual definition of a complete linkage. And here you can see that there is a complete linkage at the edge to edge. But I think that there is a little bit error in this figure, and in actual we will just calculate the uh, first of all, there is no any way to calculate the edge of this circle, but yes, we are actually measuring the distance between this x and this x. So which are too far, or you can see that, yeah, not this one. This one is too far. So this x, this data point and this data point. This one is a first cluster and this one is a second cluster, and this x belongs to the second cluster, and this axis belongs to the first cluster. So in a complete linkage, we are actually finding the distance between the uh, you can say that there is a which data points are too far from each other. So this x and this x are actually too far from each other. If we take the consideration towards this x towards this x, then this is a very short, and this one is also short. But yes, the longest distance between the data points, and this one is there is a x. This x is there, and this x is there. So we can just simply calculate the distance between these two data points. Let us a little bit in details. And yeah, single linkage defines the distance between the cluster as the distance between the closest two points. So this is one of the most important point in a single linkage, the distance between the closest. So these two axes, these two data points are very close to each other. So on the basis of that, we can say that this one is a single linkage. That is or a simple linkage. In another, the distance between two clusters is basically in this case they have defined this one is a CJ and this one is a CK cluster. Measured by the single link is described by the formula which is given in okay given here, and where CU are the two clusters and merged together whatever. Oh, okay, the basic equation is to identify the distance between these two clusters. There is a this kind of this is a two clusters, and this is a this is you can say that this is a operational code or operand which is used to compute the distance between these two clusters, and we have to find the minimum distance. We have to find the minimum distance between this cluster. For example, this one is the first cluster and this one is the second cluster. We have to identify the clusters. So this is a equation, and we will try to cover this equation in the practical part. And let us do with another part. There is a complete linkage method. Now here you can see that there is a complete linkage defines the distance between the clusters as the distance between the two farthest two data points. Yes, basically in this figure, I have already told you there is a little bit error in this figure. The actually what we are doing, we are identifying the distance between these two data points. So on the basis of that, we can say that this one is a complete linkage. You just please note it down, or you can just correct this graph. I just remove it, so you remember that. Oh, yeah, I have just removed it. You have to remember that the distance between the longest distance between the two data points, and there is a simple equation is there. There is a maximum. We have to follow the maximum of operand to identify the distance between these two clusters on the basis of the data points. So yes, it is very sensitive to the outliers because they are far from each other. Yeah, there is a kind of a sensitiveness in a complete linkage. You can remember that. And yes, basically there is a very I have just put it here. There is a centroid method or a average linkage method. Specifically, there is no any difference between these 2 points, but yes, little bit they have defined as a different terms. So we will do with these two terms. There is an inner average link. First of all, the figures of both the methods are same, but what is the difference? Let us see. The distance between the two clusters is the average distance of all pairwise distances between the data points in the two clusters. So you have to remember that between the data points, distance is average distance, all pair of the cluster in a centroid, which is actually exists at the center of the you can see that the center of the cluster. So in a centroid, they are definitely they are also based on the centroid. and they are just calculating the distance between the directly taking the distance taking the distance between the centroid of different clusters. This one is a one cluster and this one is a second cluster. So in actual, there is no any not a difference between average, link, and centroid method. But yes, they have been little bit defined with the different terms. So the diagram of both the methods are same. You just have to remember that. In the case of the average, we have to take the average distance, and in case of the centroid method, we are taking the distance between two centroids. So there is only difference between these two terms, but actually physical appearance of both the methods are same. So yes, if there is any question, then you can just ask. Otherwise, then after 5 minutes, we will start with the regression analysis. Yes, please. If you have any question, then you can please ask related to the hierarchical clustering or the different methods to measuring the distance between two clusters. I will give you 5 minutes. So if there is any query, please you can unmute your mic or you can just ask me on a chat box. Okay. Hello. Am I audible to you all? Just please, you can mark your attendance for yesterday, and please note that this topic we have to cover yesterday, and uh, but yes, first please note that you have to mark this attendance, and the links has been changed. First of all, dear all, just please remember that the links for attendance have been changed. So you have to click on this link to mark your attendance. And while marking your attendance, please remember that you have to put the date of 3rd of August so that I can mark your attendance for that day. And after the attending the another lecture, you will get the attendance for today. So please note that you are attending the 2 lectures today, and you have to mark your attendance for yesterday for now. Yes, please. If there is, if once you have marked your attendance, then please confirm me. Yes, once you have marked your attendance, please confirm me. Yes, okay, Rishabh and Kshitij. Okay, if there is any problem while marking your attendance, then please let me know. And if you have marked your attendance, then please confirm me. So hopefully you all have marked the attendance for yesterday, not for today.